So the last skill we learned was how to graph a rational function. And oftentimes, you're going to be dealing with rational expressions, rational functions in a problem. You need to know how to make them look simpler. Simplifying a rational expression is talking about basically cleaning it up and making stuff cancel out that does. First of all, this problem right here is simplified. We have done this before. All of you guys should be able to do that problem right now using properties of exponents. If you just look at your numbers right there, ignore the x's for a second. You have 15 over 25. 15 over 25, if you reduce it, reduces to 3 over 5. And if I have 3 x's up top and 2 on the bottom, there's going to be 1 left over. It's going to be on top if they cancel. So my answer is 3x over 5. That's simplified. So we've already been doing a little bit of rational expressions before we even knew what they were. Now, the second part of the instructions here says state any excluded values for x. In other words, what numbers would have been bad to plug in for x that we don't want to use, that we want to exclude and say we don't want? If you look at this problem right here, really what this boils down to is what numbers would make you divide by 0? When you have rational functions, you get to be really careful about dividing by 0. That's, like I said, the worst thing you can do in math pretty much. You do not want to mess with that. So I need to figure out what number I can plug in for x to make this guy equal 0. Well, if I plug in a 0 for x, I get 25 times 0 squared, which is 25 times 0, which equals 0. That's really bad. If I plug in a 0 for x, I just divided by 0. So I need to exclude that value and say x can't equal 0. So the excluded values basically means make a list of what numbers you're not allowed to use for x. In this problem, if you plug in a 0 for x, you will divide by 0, which is bad. On our second problem here, same instructions, we're looking at this. So we have a more complicated problem here. Now, some people might be tempted on this problem right here to be like, oh, x squared over x squared, cancel, they go away. You are not allowed to do this. You cannot just cancel out those x squared because of these little plus signs right here. The way that my teacher taught me when I was in high school, she said, pretend there's little plus signs and minus signs are like a little guy right here, little stick figure. Got another little stick figure right here. If you cancel those off, this guy was holding on to the x squared right there, you just kind of tore off his arm. You broke off his arm. She would always tell us, don't break the arms. And as dumb as, as silly as that seems, it actually seems to work pretty well for me. It always stuck with me, and it sticks with both kids. When you see pluses or minuses, you cannot just cancel. On our last problem, there was a times sign in between right here. So when we cancel things, that's fine. You can cancel when it's multiplication. You cannot cancel in a situation like this. So what we actually have to do here, what we have to do on this problem is do our magic numbers. We're going to factor these things and hope that when we do, something ends up working. So I'm going to factor my top right here. I need two things that add to 8 and multiply to 15. Ends up being 3 and 5. Since it's just an x squared, I can use my shortcuts and just write it in the parentheses. So I get x plus 3, and I get x plus 5 in parentheses here for my top. If you do the same thing on the bottom, you're going to end up with, it looks like x plus 3 and x minus 1. Again, verify that by checking, but you factored that's what you end up with. Now, if you look at the pieces we have left over, I have matching x plus 3's right here. And since I'm multiplying the parentheses in this situation, I am okay to cancel those. I didn't break any arms, so I just wipe out those little parentheses. These just go away. So my final answer after those cancel is x plus 5 over x minus 1. Nothing else is going to cancel. You just leave it like that, like it is in green, and you're done. Now we have to give the excluded values. What numbers would have been bad to plug in for x? Well, if you look at the final answer right here, x minus 1 is on the bottom. Man, it'd be really bad if there was a 1 down there for x, because we'd have 1 minus 1, we'd get 0, which is bad. We divide by 0. So we definitely don't want x to equal 1. Then we would divide by 0. The other number that would be bad for x, even though it canceled out, in our blue step right here before it canceled, if we would have plugged in a negative 3 for x, we'd get negative 3 plus 3, which is 0. So x can't equal negative 3 either. You have to cancel out those two values. Those two are not allowed. If you did, you divide by 0. So you say x can't be them, and you're done. One more problem in this video. Taking one more example right here, I want you guys to go ahead and pause the video and do your magic number process on this problem. When you do your bottom, you can't use the shortcut. You're actually going to have to split it up into 4 pieces and everything. So pause the video, try this one, and see what happens. I'm going to go ahead and work it out. So realize the top right here is x squared plus 0x minus 16. You need two things that add to 0 multiplied negative 16. They end up being 4 and negative 4. So the top factors into x minus 4 times x plus 4 if you do your magic numbers. On the bottom right here, I'm going to go ahead and just tell you guys what's going to happen with the bottom. If you factor it, though, and you did it correctly, you should get 2x minus 5 and x plus 4. Not necessarily in that order, but it's fine. If you need help with that, definitely let me know, and we can practice factoring. But that's breaking into 4 pieces. Once you get to this point right here, notice I have x plus 4 on the top, and I have an x plus 4 on the bottom. It's okay, they don't have to be like directly underneath each other, but if there's one on the top and bottom, I'm going to cancel it out, just like we did in the last problem. They wipe each other out, they're gone. So my answer is x minus 4 over 2x minus 5. I have to give my restricted values here. First of all, the easier one of the two. On this piece right here, x can't equal negative 4. Even though it cancels out, that's bad. We would divide by 0. The other piece comes from this guy right here. You do a little bit of math on the side. 2x minus 5 set it equals 0, and figure out what x is. You end up getting x can't equal, you get 2.5 for that. So x can't equal 2.5, and x can't equal negative 4. Those are our excluded values.